Bismillahirrahmanirrahim. Good to see you again. Thanks for returning to Biochemist Corner to learn some more biochemistry with Ms. Biochemist. As we were studying biomolecules and we arrived at lipids. Before we begin, I would like to ask you a question. Have you ever wondered how lipids can be both energy boosting and harmful? So get ready to explore. Welcome to Lipid Learning, your go-to source for lipid-related insights. Subscribe for all episodes on lipid biology. Let's get started.
Lipids are a group of biomolecules that play important roles in living organisms. While the primary function of lipid is long-term energy storage, lipids are also used for protection, insulation, and lubrication. They also act as a precursor for some hormones and are a key component of cell membrane. Lipids include things like fats, oils, and steroids. And the key characteristics that define them is that they are largely nonpolar, composed predominantly of long hydrocarbon chain or ring system. They are hydrophobic biomolecules.
There are four basic groups of lipids. These are triglycerides, phospholipids, steroids, and waxes. Although these groups differ in many respects, they all have one characteristic in common, that they are all insoluble in water.
You may have noticed that lipids and water do not mix. An example, notice the yellow colored oil in a bowl of water shown here. Even if we stir this for several minutes or even for several hours, the oil would still separate out from the water. This is because lipids are hydrophobic. From Latin, the prefix hydro means water and phobic means fear of. So, when you say lipids are hydrophobic, this basically means that water and lipids do not mix.
Let's look at triglycerides. Triglycerides are molecules with three ester groups, and examples include peanut oil, corn oil, and butter. Fats that are liquid at room temperature are called oils, and if they are solid, they are called fats. These molecules can differ in the type of acyl group they possess, which is this portion of the molecule which will always be a hydrocarbon chain of some length. If these ester groups are hydrolyzed, meaning a hydroxide attacks each carbonyl taking up this portion of the molecule, we get glycerol and three fatty acids. They are called fatty acids because they are carboxylic acids, but they also have long non-polar hydrocarbon tails, which can vary depending on the tag the fatty acid is derived from. Most of the time, this tail is unbranched and contains an even number of carbons. If it contains all carbon-carbon single bonds, this would be a saturated fatty acid because it contains the maximum number of hydrogen atoms possible. If there is a double bond, it's an unsaturated fatty acid. Sometimes there are two or three double bonds which would make it a polyunsaturated fatty acid. In naturally occurring fats, the double bonds are almost always cis. When we hear about trans fats, these are the ones that seem to be harmful to the human body, as their linear shape gives them a higher melting point, so they are more likely to remain solid and more difficult to metabolize. These are associated with cardiovascular disease. In general, saturated fatty acids have higher melting points than unsaturated ones because the double bonds restrict rotation and therefore cause a kink in the chain, which interferes with crystal packing. Saturated fatty acids can pack neatly and maximize van der Waals attractions. That's why butter, which is fully saturated, is a solid at room temperature, whereas olive oil, which has a degree of unsaturation in one of its hydrocarbon chain, is less able to form an orderly solid lattice and is therefore a liquid at room temperature. An omega-3 fatty acid is one where the third carbon from the end of the chain is participating in a double bond. When we talk about hydrogenated vegetable oils, these are derived by hydrogenation some of the double bonds in polyunsaturated fats. One problem with partial hydrogenation is that it can sometimes isomerize double bonds, turning cis into trans, resulting in trans fat, which, as we said, should be avoided. In general, fats like tags are used as energy storage. When these are metabolized in our bodies, they release twice as much energy as carbohydrates, since there are so many carbon hydrogen bonds. Furthermore, Polysaccharides like glycogen only provide energy for about a day, whereas the fats we store that make up around 20% of our body mass provide long term energy storage, which would keep us alive for up to a month without any food intake if necessary. Still, there is much discussion about how much saturated fat and unsaturated fat should be in our diet, but we will have to examine that another day. Thanks for watching and stay tuned for more upcoming lipid tutorials.